All right, the next problem asks you to find the points of intersections between these two polar graphs. So if you remember from algebra, we're talking about systems of equations, and in algebra, when we were graphing on a rectangular coordinate system, we didn't really have to graph the points or graph the functions and then see where they intersect or anything like that. We could just use like algebra. So let's just see what happens when we do that. We've got r equals this and r equals this, so obviously I can just say this, 1 plus sine 2 theta is equal to 2 sine theta. And then I suppose I can subtract sine theta from both sides, and I'll get 1 equals sine of theta. Okay, and that would mean that theta is equal to like pi over 2. Okay, or I suppose, this is right here. It could be like 5 pi over 2, 9 pi over 2, etc. So this is like theta is pi, all these different things. I could write it as pi over 2 plus 2 pi times k, we'll say, where k is an integer. And then r, if I plug in, if sine theta is 1, then r is 2. So it would be like, according to the algebra, it should be at 2 comma pi over 2 plus 2 pi k, where k is an integer. So there's an infinite number of, I guess, intersection points. But let's see what that looks like on a graph. So I want to graph this and just see how this looks. So, okay, give me a second. All right, so I'm now going to graph this. And so if I want to graph 1 plus sine of theta right here, I'm going to graph that. I'm going to graph y equals 1 plus sine of x real quick on a rectangular coordinate system so that I can transfer it over to the polar coordinate system. And so all this is a sine graph shifted up 1. So I'm just going to make my new axis of wave here. And these are all at like pi over 2s and so forth. And so instead of starting here, I'm going to start up here. I'm going to go to the top, to the middle, to the bottom, back to the middle. Okay, and so this is how this looks. And it continues in this fashion there. So let's graph that on the polar grid. And I can see that the highest ever goes 2. And I think I messed this up. This is not sine of 2 theta. I believe it's just 2 sine of theta is the other one that we're graphing. Okay, so anyway, back to the one that I'm actually graphing here. Now we're just going to create this on the polar grid. And so we'll have to kind of look at a couple of different things here. But the angle here is 0 and the distance is 1. Let me make a scale. I'm going all the way to 2, I think. So I'm just going to make it like, here's 1. Actually, let's just do it like this. 1 and 2. So this is 1, this is 2, and so forth. Okay, so here, the first point is, I'll make it in black here, is there. Okay, and then the next point is pi over 2, 2. So we're up here, and then really if you think about it, pi over 6, the sine of pi over 6 is 1/2, and so at pi over 6 we're going to be at 1.5. So this is going to kind of look like this, okay? And then we continue on here. At pi we're back at 1. This is not pi. Sorry, I'm confusing myself. Pi, we are at 1. Okay, and then I'm tweaking here. 3 pi over 2, we're at 0. So we're here. So this is how this is going to go. This is actually, we're going to go to the pole. And then we're going to go like that. Okay, so that's that graph. Okay, now, let me just check something really quick. Okay, now if we're going to graph this, okay, I'll make the rectangular graph very quickly. Okay, we know that the amplitude is 2. Period is 2 pi, so I'll break that into quarters. Okay, and we start at the middle. Okay, we go to the top, to the middle, to the bottom, back to the middle. So here's what y equals 2 sine of x looks like. Okay, so we're going to use the same grid here. So it says that this is, so we start at the pole, 0, 0, and then we're at pi over 2, 2. So we're up here. Now let's plug in something else, like pi over 6. At pi over 6, 2 times the sine of pi over 6. That's going to be at 1. At pi over 6, we're at 1, so we're here. Okay, and then, so it's like this. All right, and then at pi, we're back at the pole, so we're going to kind of go like this. Actually, this is a circle, and it looks like a horrible circle here, but it's a circle. And where do we intersect? Well, we do intersect here at pi or 2 comma pi over 2. Okay, and that's what we said would happen. But we also intersect here at the pole. And so here's the thing about, where do two polar graphs intersect? Well, if we ever hit the x-axis, if both of them hit the axis, you're going to go through the pole. Okay, and there's an infinite number of ways you can express this point. Basically, if r is 0, this angle could be anything. Okay, so the lesson here is that we can solve the algebraic equation, like we did here, to find the intersection points. Okay, but that may not give them all. It may also intersect at the pole. Okay, I just wanted to use that problem to point that out. Okay, so the next problems you're going to do are going to be basically to practice some polar graphs. And so you'll do that next.